Number 1, what are 2 factors of 50? 2 and 25. So if I wrote it, okay, separately, like this. I expanded the p cubed to 3p's, right? Square root of 25 is what? 5. Can't do anything with the square root of 2, so that stays in. Now, for square root of p cubed, I'm looking for a pair. So I have a pair of p's, so 1 comes out. Whatever I did not circle stays inside. Okay? Number 2 is also correct. 10m squared root 2n. Okay? Any questions on number 2? Okay? Number 3 is also correct. 2xy root 7xy. Any questions on that one? Okay? Now number 5, one thing we have to do here. Well, there's something missing. Okay? Number 5, the 4 is on the outside, which some of you probably didn't notice. Okay, so 4 is on the outside. However, square root of 50 can be simplified to what? Yep. 5 root 2. So this is 5 root 2 over 2. This is over 1. Okay, so we multiply 4 times 5, which is 20 root 2 over 2. 20 divided by 2 is, you're left with 10 root 2. Okay, some of you probably didn't see that the 4 was attached to it, and just left it 5 root 2 over 2. Yep. Okay, so what you have to do in this, you have 4 still on the outside, but you have a fraction, so it's 25 over root 2. Square root of 25 is 5, but we cannot have a radical in the denominator. So the 4 still carries over from the outside. Then 5 root 2. Root 2 times root 2 is just the number inside. And then we have what's up there. And then number 8 is also correct. Number is negative 10. Okay? Because you can multiply that too. And 5 times 20 is 100. So the square root of 100 is 10. There's a negative in front, so negative 10. Okay? All right. The number 10 I didn't assign to anybody. The reason is it could be a little confusing. Okay? We are multiplying, right? So root 2 times root 6 is what? Liv? So root 12, we're not going to do anything yet right now. Then root 2 times root 10 is what? Root 20. Okay. So now from here, okay, all we did were multiplying radicals. We could do that. Okay. Root 2 times root 6 is root 12. Root 2 times root 10 is root 20. How can I simplify the square root of 12? Okay. What does that simplify to? These guys, root 12, root 20, root 8, those should come second nature. Well, to root 3. How do I simplify square root of 20? Yep. To root 5. Okay. This is as far as you could go. The reason is, root 3 and root 5 are not like terms. Okay, so when you're adding and subtracting, and we're not going to do much of that, but if it does come up, these guys have to be exactly the same. That's like, can you combine, think of your linear equations, would you be able to combine that? No, you would only be able to combine if it was like this, correct? So that's the same thing with the radicals. If I had 2 root 3 plus 3 root 3, sorry, then I'm able to combine it to add 5 root 3. But if they're not like radicals, I have to leave it as is. Okay? Any questions? Were there any questions, and I meant to ask at the beginning, on the homework at all? Yep. Number 22, you have a radical over their entire fraction. So it's 20 divided by 5, which is what? What's 20 divided by 5? 4. What's the square root of 4? 2. Okay. So when you have it like this, if the radical is over the entire fraction, or even if it's not, you can divide 20 divided by 5. It's root 4, which is 2. You don't need to, because it could simplify. But say if you did, you have root 20 over root 5, right? And you multiply, let's just say, 20 times 5 is 100. Root 5 times root 5 is 5. What's the square root of 100? What's the square root of 100? 10 divided by 5? To root 5 over root 5. That radical is over root 5. Cancel out. Yeah, Devin. Number 10? Sure. Okay. Number 10. Okay, the 2 is already on the outside. What are 2 factors of 48? What are 2 factors of 48? And again, you could have kept it under 1. I just split it. So what's the square root of 16? Can I do anything with that? Nope, so that stays inside. How about here? Yep, just x. Now here, y squared, and there's nothing left over. So whatever is not circled stays inside, and now I multiply. So 8xy squared root 3. Okay? Yeah, look. Number 4? Number 4. Okay. Number 4 square root of 80. What are 2 factors of 80? Okay. Then what? Can you keep going? Okay. Every pair, 1 comes out. 1 pair of 2s. 1 pair of 2s. Whatever's left over stays inside. You see what you... Okay. Right. Any others from the homework? Okay. I want you guys to look at, and we're going to be jumping around a little bit today. On page 9, I want you to try 29. Okay? Try 29 on page 9. So it's square root of 3v times root 6 plus root 10. We just did something similar to this. Okay? Yep. Yep. Because you're multiplying. So number 20. Okay. So far with 29, you're able to multiply 3v times 6 to get 18v and 3v times 10 to get 30v. Any of these can we break down even more? Well, yep. Good. 3 root 2v. We can't do anything with 30v, so that stays as is. How many of you got that for your final answer? Okay. Any questions? Yep. Think of your factors. 3 and 10, 5 and 6. There's no pairs there. Okay? So I want to look at 40. Okay? This is 4 over 3 minus root 6. Now, we cannot have a radical in the denominator, correct? And the only time we have seen a radical in the denominator is, say, if it was something like this, right? Where we would have to multiply top and bottom by root 3. But now we have an expression in the denominator, 3 minus root 6. So the only way to get rid of that is multiplying by something called the conjugate. Okay? The conjugate simply means the opposite. Okay? So, if we have 4 over 3 minus root 6, so anytime you have an expression with plus or minus in the denominator, you are multiplying top and bottom by the conjugate. So, in this case, I am multiplying by 3 plus root 6, 3 plus root 6 top and bottom. So if you notice, the only thing that changed is that middle sign. Okay? So now, what this looks like, if I was to write it on one fraction, okay? If I was to write it all together as one fraction, this is what it would look like. Okay? 4 times 3 plus root 6 is your numerator. Then in the denominator, 3 minus root 6 times 3 plus root 6. We're going to do this all out so you see how the radicals are eliminated. Okay? So what would I have to do? What operation would I have to do in the numerator here? What do you think? Yeah. Distribution. So 4 times 3, 12, plus 4 root 6. You can't have root 24 because there's no radical with the 4. Okay? So it's 4 root 6. Now, the denominator. Since we have 2 binomials, we will be using FOIL. Okay? First, outer, inner, last. Which is just multiplying, you're distributing both. Okay? What is 3 times 3? 9. Okay? 3 times root 6 is what? Negative root 6 times 3. Negative root 6 times 3 is negative 3 root 6. Now, negative root 6 times positive root 6 is just what? Negative what? Okay. Because, excellent, when you have a radical and multiply by itself, you end up with the number inside. Okay? So, everyone okay? Okay. Negative root 6 times positive root 6 is negative root 36. Root 36 is just 6, so you end up with the number inside. Okay? So now, you have 12 plus 4 root 6 is just your numerator. What's going to happen to these middle terms? Cancel out. So now you're just left with 9 minus 6, which is what? 3. So, that's your final answer. Okay? Some of you might look at, oh, there's 12 over 3, so I could simplify. Okay? You could only simplify if this denominator goes into both of those terms. If it doesn't, leave it. Okay? So the whole idea about multiplying by the conjugate is it gets rid of those radicals. Okay? So I know I crossed out 41, but that's the one I want you to do. Okay? What are you multiplying top and bottom by? Yep. 7 minus root 5. Good. All right, go ahead. Hey, for 41, how many of you did get 35 root 5 root 5, 35 minus 5 root 5 over 44? Good, good, good. Okay, so when you distribute, you have 35 minus 5 root 5, then you have 7 times 7, which is 49. You automatically should know the middle terms cancel. Then if you do root 5 times negative root 5 is minus 5, and that's how you get the 44. Okay? Any questions? Okay. Okay. So when we are using radicals, if we're simplifying, if we're multiplying, if we're dividing, okay, we got to make sure, A, there's no radical in the denominator. If there is, we either rationalize or multiply by the conjugate, okay? We always want to simplify, okay, wherever we can. So we shouldn't have square root of 8, square root of 20, square root of 16. We shouldn't have any of that in any part of our answer, okay? So I'm going to kind of switch gears. What would happen if you guys had like square root of negative 3? What would you call it? Square root of negative 3 as an answer. What would happen? What would you say? Yeah. You can't have that, right? That's what we're used to. You guys probably don't know what it is yet, but if we see a negative, problem's over. There's no solution, right? Yeah, Liv. It is an imaginary number, and that's where we're switching gears right now, okay? Because they go hand in hand. Surprisingly, when we get to the imaginary, a lot of the simplifying was like this in my last class, okay, which I'm assuming is going to be the same thing, okay? So we are now identifying that if you have a negative inside a square root, excuse me, yes, you can simplify, but now it has a name. It's our imaginary solution. It is our complex numbers that we're looking at, okay? So if you switch the page to here, okay, this is where we start to identify our imaginary unit, which is I, okay? You're going to hear me say over and over and over again, if you see a negative inside a square root, the I comes out, okay? So that is going to be stuck with you every time you have to simplify square roots and there's a negative, okay? So here's an example of what it looks like. If I have a square root of negative 5, automatically that negative and I comes out and you're left with that positive root 5, okay? This little circle below, on mine it's hard to see because it was scanned in, so this little circle is what we have to memorize, okay? This little circle repeats the process every 4, all right? So anything to the 0 exponent, I to the 0 equals 1, okay? I to the 0 equals 1. The next one, next term, is I to the first, which is I, okay? The bottom there is I squared, which is negative 1, okay? And I cubed is negative I. Then it repeats the process, okay? I is the square root of negative 1. That's why if we see a negative inside the radical, an I comes out. How we get to I squared is what happens when we multiply a radical by itself. What's square root of negative 1 times square root of negative 1? Do we get the same number inside? Yes. So this is negative 1. When you multiply a radical by itself, you get the number inside. Okay? Then I cubed is made up of I squared times I. But what does I squared equal? Negative 1. What's negative 1 times I? Just negative I. Okay? I'm just giving you the backstory of how they came up with I squared, I cubed. It has to deal with the square root of negative 1. Okay? I to the fourth is made up of I squared times I squared. What does I squared equal? Negative 1. What's negative 1 times negative 1? 1. That's where it repeats the process. So, whenever you're given I to a specific exponent, okay, you want to divide by 4. Divide the exponent by 4. And your remainder, the remainder will either be 0, 1, 2, or 3. Okay? Your remainder will either be 0, 1, 2, or 3. So the first couple I'm always going to refer to its equivalent to. Okay? However, we don't even have to do that part. You should know it's either going to be 1, I, negative 1, or negative I. So for example, 4 goes into 5 how many times? Once. How many are left over? 1. So I to the fifth, because there's a remainder of 1, is equivalent to I to the first, which is what? Just I. Okay. 4 goes into 5 once. There's 1 left over. So it's equivalent to I to the first, which is I. 4 goes into 6 how many times? Once. How many are left over? 2. So I to the sixth is equivalent to I squared, which is what? Negative 1. So this equivalent piece, do you always have to say it? No. You could just give me what it is. It could be 1, I, negative 1, negative I. Okay? 4 goes into 7 how many times? Once. How many are left over? 3. So I to the seventh is equivalent to I cubed, which is what? Negative I. And the last one, so you could see it come full circle. 4 goes into 8 how many times? Twice. Anything left over? No. So I to the eighth is equivalent to what? Which is 1. Okay? So it repeats the process every 4. You just have to know if, when you divide, the remainder is either going to be 0, 1, 2, 3. Okay? So there's a few I want you to try. Yep. 4 goes into 8 how many times? Is there anything left over? No. So it's I to the 0, which is 1. Okay? So I want you to try I to the 52nd, 63rd, and 16th. Okay, so divide by 4, and your remainder is going to be either 0, nothing left over, 1 left over, 2 left over, 3 left over. I to the 52nd, which one is it going to be? 1, I, negative 1, or negative I? What is it, Cliff? 1. Good. 63rd. 1, I, negative 1, or negative I? Hello? Negative I. Good. And 16? 1. Good. So say if you put these in your calculator, right? And say if you did, and you did these divided by 4. If you got a decimal of 0.25, how many is left over? Good. That's equivalent to 1/4. 1 left over. How about 50? 75. Okay, so if you see these in your calculator, and it's 0.25, you have 1 left over. 2 left over. 3 left over, because people will put it in your calculator. I know that. Okay? Questions? Okay. So, the whole big picture is when you see a negative inside a square root. Okay? So, for example, in A, excuse me, you have the square root of -3. That's the square root of -1 times square root of 3. But what does the negative represent? Square root of -1. I. So you're left with I root 3. That's how it would break down. But what I want you guys to know is as soon as you see a negative, take that I out. You don't have to break it down like this. You could automatically take out the I. So for example, in B, square root of -18. I see a negative, what comes out? Now, how do I simplify the square root of 18? Yep, Jason. 3 root 2. So what this looks like is 3I root 2. The I acts like a variable, so it comes after your number. Yep.
So I allows us to take the negative out of what's inside the radical.
Correct.
That allows us to simplify.
Yes. Okay. How about C? Yep. I did. In C, I see a negative. Automatically, what comes out? I. How do I simplify the square root of 32? Yeah, Jeff. 4 root 2. So this would be 4I root 2. Awesome. Okay, you see that negative I comes out. Now, D is a little bit different because we already have an I on the outside, which is fine. So I'm going to keep it that way. However, I see a negative inside, so what comes out? Another I. Okay. Then we have the square root of 49. What is I times I? Okay, what's the square root of 49? Okay. What does I squared equal? Look above, look above. -1. -1 times 7 is -7. Okay? So when you get into, we're going to do a few more, but when you get into solving, or we will see the conjugate with this, you never want to see I squared in your final answer, because I squared equals -1. If you see a negative inside a square root, you take the negative out. Okay? Let's look at E. I have I automatically on the outside already. If I see a negative inside, what comes out? I. Okay. Then how do I simplify the square root of 90? 3 root 10. So I have 3 I squared root 10. What does I squared equal? -1. -3 root 10 is your final answer. Okay. Now if we look at F, you just have a -1 on the outside. Okay, you just have a -1. Keep it as is. If I see a negative inside the radical, what comes out? I, okay? Then how do I simplify the square root of 54? Yep. 3 root 6. So I would have negative 3i root 6. The negative is just a negative 1, so that's why it's on the outside. Okay? I want you to try G and H. G and H. Okay. For G, what do we have? For G, 7. Negative 2 root 6. How many of you did get that? Okay. So we have I automatically on the outside. If we see a negative, automatically what comes out? I, then we have square root of 24. So we have I squared. Square root of 24 is root 4 times root 6. 2 root 6. I squared equals negative 1. Negative 2 root 6. Right? How about H? James. 11 is correct. How many of you did get 11? Okay. So we have negative I on the outside. So we just bring that down. If I see a negative, automatically what comes out? I. Then we have negative times I squared. What is the square root of 121? What does I squared equal? Negative 1. Okay. When I multiply all of those, negative times a negative, what do I get? Positive, and you're left with 11. No, I didn't ignore it. I just brought it down. Okay, I squared equals negative 1. Okay, so we're going to try a few practice problems on the next page. And we're going to go through these. So 1, 2, 3, 4, 6, 8, 10, 12, 14. So we should be circling these as I went through them. 1 through 4. Then our evens. 6 through 20. Okay? So 1 through 4. 6, 8, 10, 12, 14, 16, 18, 20. Okay? I want you to go through those. And again, if you get stuck, ask someone next to you.